Dear professors, today my presentation is about continuum robot for quadruped robot applications. Continuum robots such as botanic elephant trunks and botanic nails have attracted extensive attention in industries. To enable them better apply to various fields, we propose several design aims: dexterous manipulation capability, relatively simple structure, convention manufacturability. First, we designed 3 different types mechanism based on steel-wood. 2 rigid continuum robots are shown here. The driving arms of the left are cylinders, while the right are 2 sliding pairs with springs. The steel-wood-based mechanisms have more degrees of freedom and are more maneuverable. In self-compliant one, each driving arm consists of 1 parallelogram compliant moving hinge and 2 compliant spherical hinges. The characteristic of it is easy to monolithic manufacture. Additionally, 2 kinds of robots that directly connect by compliant mechanism in serials are designed. The left one is based on butterfly pivot. It is hollow miniaturization and can monolithic manufacture. The right one is based on folded leaf spring. Compared with the left one, it has large motion range and have dexterous motion capability. We innovatively proposed 3 unactuated driving systems. The first one is pneumatic actuation system. The whole mechanism is connected by air pipes and driven by gas pressure from the air pump. Another one is cable actuation system. The moving hinge set on each driving arm of the steel-wood parallel mechanism includes 2 components with fixed pulleys that can produce relatively parallel movement. A pre-compressed spring is set between the 2 parts to push them apart, so we can control the elongation or shortening of the driving arm from wrench. The last one is also a cable actuation system. The difference between it and the former one is that the pulley fixed on the plate and the cable can not only provide the driving force for the robot, but also act as a spherical joint to ensure that the driving arm rotates to the target attitude. A single steel-wood cell forward kinematics, inverse kinematics, and static mechanics modeling of the robot are carried out. For whole robot, we use constant curvature to modeling it. Since we use Fernet series, so it is simple and accurate to calculate. Kinematic simulation is carried out. In left part is 4 different moving simulations of a robot composed of 20 cells, while the right are comparisons of analytic and FEA results. Finally, we fabricated some prototypes of mentioned mechanisms and did some experiments. The rigid one, driven by cable and spring, is shown here. Compliant robots are also fabricated and tested. The left one has well-behaved adaptability, while the right one can be miniaturized, and both of them can be monolithic manufactured. Last is a folded leaf spring-based one. Compared with the pivot-based one, this prototype has large motion range. We propose a quadruped robot. The proposed continuum robots are applied on it as tails and trunks. In future plans, we will further improve this mechanism. Many thanks.